This is number 7. We are to tackle the question number 7. Number 7 reads, the point P and the Q have coordinates at 5, -6, and -3, -8 respectively. Calculate the gradient of the line PQ. Alright, so if these are the coordinates of the given points, which is P and the Q, so it simply means any line which joins these two coordinates is going to be a straight line. Since they are just the two coordinates, they form a straight line when they are joined. So in other words, we are on coordinate geometry. This question is from coordinate geometry is the topic. So the first question requires us to calculate the gradient of the line PQ. Since it's a straight line, equation of a straight line, gradient is equal to increase in y over increase in x, or you can say change in y over change in x. Alright, so these formulas, they are the same. Change in y over change in x, or increase in y over increase in x. So what you need to do is you rewrite the coordinates, which is -3, -8. Then you name these coordinates. We know that the coordinates of a point are given in the format x coordinate and y coordinate being the second. So the first will be the x coordinate and the y coordinate. So meaning to say here, this one is the x coordinate and this one is the y coordinate. This one is the x coordinate and this one is the y coordinate. So since we have the x coordinate here and also the x coordinate here, we can name the first one being the first coordinate and the second being the second coordinate of x. Then this one, the first coordinate of y, and this one the second coordinate of y. You can, the naming of x1, y1, y2, x2, it doesn't matter. You call this one the x1 and this one the x2. It doesn't change anything. Only that you need to know that this is the x value, so it should be the x1 or x2, not the y1 here. Then, so to show the increase in y or to show the change in y, we show by the movement from the first coordinates to the second coordinate. So to indicate that movement, we say coordinates of either of y2 and x2 minus the coordinates of x1 or y2. So the formula is simplified to y2 minus y1 all over x2 minus x1. So this formula, it gives us the change in y or the increase in y over the increase in x. So by subtracting the coordinates of y1 from y2, it gives us the change or the movement from point 1 to point 2, or to point from point P to point Q, right? So we are going to have grad is equal to y2, the value of y2 is minus 8 minus, which is the negative here, minus 6 all over x2 is minus 3, then the negative from the formula, then minus 5 is our positive. So we are going to have simplified to minus 8 plus 6, double negative gives us a positive, minus 3 minus 6. So if we simplify minus 8 plus 6, it gives us negative 2. These are directed numbers. Negative 3 and negative 6 gives us negative 9. It gives us negative 9. So that's the situation at hand. Minus 3. So that's it. X2 it's minus 3. Here is minus 3. Minus 5, which is the x1. It's like this. Oh, sorry, this is minus 5. I made a mistake. So we are going to have negative 8 here. So by simplifying, we are going to have minus 1 over minus 4. So the negative is going to cancel each other, so the answer is going to be 1 over 4. Right, so the gradient is equals to 1 over 4. Then we move on to part B. The part B wants us to do not cancel that with just an extension. Part B, find the equation of the line PQ. So after calculating the gradient, we are then required to find the equation of the line PQ. So the first thing we need to know is PQ is a straight line. It's a straight line. So the straight line equation is given in the format y is equal to mx plus c, where m is the gradient and c is the y intercept. So the value of c is where the line crosses the y-axis. Let's say we have this Cartesian plane. Here it's x, here it's y. So let's say this is our equation, our straight line equation. It crosses the y here. So the value of c is going to be the value of y at which the equation crosses the line y-axis. So that's the situation. So we are going to have our equation from the starting point will be the gradient, and we pick any one of the coordinates that we are given. So we choose either Q or P, whatever coordinates. Let's say we chose 5 minus 6 is the coordinates. We choose P, right? So we create an imaginary coordinate, which is called x and y, the imaginary coordinate, which is we say, let's say this is P. We imagine that we have also another coordinate, which is this one, along the line. So we create an imaginary coordinate or point, which is x and y. So, and we rewrite the equation for calculating gradient, which is change in y over change in x. But this time now, we are going to use this as our y2 values and x2 values. So we are going to have y minus 6 all over x minus 5. Then we equate to the gradient that we calculated. This one is going to be the gradient that we equated to. So now it's now an equation, a fraction equal to a fraction. So it's going to be y plus 6 over x minus 5 is equals to 1 over 4. Then we cross multiply the denominator. It's going to multiply the numerator and the denominator here to the numerator here. So we're going to have 4 multiplying y plus 6 is equals to 1 multiplying x minus 5. Then this gives us 4y plus 24 is equal to x minus 5. Then our equation must be in the format y is equal to mx plus c. So we have to make y the subject of the formula. So we leave 4y on the left side, then we collect other values. Minus 5 minus 24, and then it gives us 4y is equals to x minus 29. Then we divide by 4. Y is going to be 1 over 4 x minus 7 and 1 over 4. So this is the equation of the straight line. So that's how we do it.